So I will officially welcome you to the third virtual Citrus session of the season for the Winemakers Research Exchange. If I don't know you, my name is Joy Ting, and I am the Research Enologist and Extension Coordinator for the WRE, and we are just thrilled that you're here today. So today's topic, we'll be talking about carbonic maceration and whole cluster inclusion, and we'll get to that in just a minute. But first, I would like to have everyone else introduce themselves. So if you would go ahead and click into the chat box, that should be part of the bottom part of your screen, and just tell us what your name is and where you're coming from today. So what vineyard or winery or entity you are representing. And as you guys do that, I'm actually going to stop sharing my screen briefly so that I can put the information for the experiments today. So if you are interested in more detail on the experiments, like the ad rates or have a take-home version of the graphs, those will be coming into the chat box in just a moment. And then I have two experimenters who are going to be sharing experiments today, and maybe I'll ask them to introduce themselves. So Kirsty, do you want to unmute yourself and introduce yourself a minute?
Sure. I'm Kirsty Harmon. I'm the winemaker at Blenheim Vineyards.
Thanks. And Tim? Looks like Tim is trying to unmute himself, and maybe, there you go.
Hey, Tim, sorry, working from my phone.
Always fun.
Yeah. Tim, Gorman, Cardinal Point Winery, and I did the whole cluster thing.
Yes, great. And we will jump into the details of those in just a moment. Oh dear, my slides went away. All kinds of fun today. Here we go. Let's see. Apologize. Here we go. Are we back up? There we go. Okay. So thanks for putting your name and your entity into the chat. We're going to start with just about 2 or 3 minutes of a little bit of introduction of a couple things to keep in mind, and then we'll jump into the specifics of our experiments for the day today. But as I said, we're going to be looking at whole cluster fermentations and a carbonic maceration experiment. So whenever we think about those, basically we're dealing with fermentations that have whole berries in them. And just a couple of things to keep in mind when there's whole berries involved. And the first of that is that really, when we think about what's happening sort of in a cross section of that fermentation vessel, we essentially have 3 different potential fractions that give a different chemical environment to what's going on in there. And it turns out that that kind of matters for what we should or could expect from those fermentations. So the first fraction are basically just intact grapes that are present. They are sort of surrounded by air. And most of the time that's going to be a CO2 rich environment on purpose. But we need to sort of think about those in one way. Then we've got sort of this fraction of some intact berries that have some form of juice around them, and most likely that juice is going to start fermenting very quickly. So again, a very carbon dioxide rich reductive environment in that juice. We'll call that fraction 2. And then usually there's at least some portion at the bottom of the tank that's analogous to a more traditional fermentation, in the sense that we have broken up grapes, we have mostly a juice environment and no intact fruit in that portion. But when we think about the different iterations of that, we can realize that we have very different proportions of those different fractions, depending on what type of experiment we're talking about. So for example, a carbonic maceration experiment has a really large proportion of fraction 1 and a very small proportion of fraction 2 and 3. Basically just whatever's gotten mushed at the bottom of the tank might be in fractions 2 or 3. Whereas when we're talking about a whole cluster experiment, a lot of times we have very little fraction 1, maybe just what's present at the top of the cap as it rises, and a lot of fractions 2 and 3. The reason that matters is because we have sort of different processes happening within intact berries versus non-intact berries that change some things about what we would expect from that fermentation. So in fractions 1 and 2, we have these intact berries that are essentially undergoing a process that we can call auto fermentation. Sometimes that process is called carbonic maceration, and sort of chemically it's carbonic maceration. But carbonic maceration also refers to a particular protocol or procedure. So today we'll sort of refer to that chemical process inside the grape as auto fermentation, just for clarity. To understand the auto fermentation, I think the easiest thing for me is to sort of take a step back and realize what cells are normally doing before they get picked, when they're sort of in their normal healthy environment. Cells are essentially metabolizing sugar using oxygen to make energy, and they use that energy to keep their cells intact, to build new cell components, to keep order, that sort of thing. When we put them in a vat like this, and particularly when any fermentation starts underneath it, or if we give them a source of carbon dioxide, eventually the atmospheric oxygen goes below 1%. And as soon as it goes below 1%, they no longer have enough oxygen to do their normal aerobic respiration. And it's at that point that they sort of switch to this process of auto fermentation. Usually that's, again, because carbon dioxide has for some reason displaced the oxygen, but that CO2 does diffuse into the grapes, and it sort of triggers a number of different shifts in the chemical processes along the way. So the first thing is basically it shifts from aerobic respiration to a more fermentation type process. Chemically, it looks a lot like the fermentation that's happening outside. But in doing that, it sort of shuts down a lot of the cellular machinery that's used for aerobic respiration, and the byproducts of that end up going other places. So that trigger ends up producing, for our wine, it produces some glycerol, acetic acid, and succinic acid, which can sort of shift some things in our flavor profile. Oops, something happened there. We also can start to see some breakdown of our cellular membranes, and that means that some things do become actually a little bit more available. So our anthocyanins, our skin tannins, start to sort of leach out. But of course, there's no alcohol in the environment there to do a real extraction for us. We also have some malic acid metabolism. So like a really full throttle auto fermentation, sometimes you'll see some depletion of malic acid, but without the concurrent buildup of lactic acid, because it's by a different cellular process. But really, most importantly, for what we'll be, I think, experiencing in the wines today, is that the normal production of amino acids usually requires oxygen. And without oxygen there, those side chains that would normally be going into amino acids go into other byproducts. And those byproducts are really a lot of what produces the strawberry and raspberry, cherry, and kind of kirsch flavors that we associate with that whole berry typicity for our whole cluster and our carbonic maceration fermentations. We also have a little bit, because we have less oxygen around, we also make fewer of the C6 compounds. Those are the ones that give us sort of tomato leaf or vegetal. So in one way, we sort of shift away from the vegetal. We'll see in a minute, we have another problem with vegetal with these types of fermentations. But then lastly, again, there's no alcohol around inside that grape. And so we don't get as much of the extraction of phenolics, and without as much tannin extraction, we also sometimes have some trouble fixing color that might be coming out. So if we have a large proportion of auto fermentation in the vat, we might expect any amount of these things to be going on. But there is a difference, though, between what's going on in fraction 1 and fraction 2. So anytime we have intact berries, any of those things can be occurring. But eventually the alcohol inside of the grape is going to build up and basically shut everything down. And that's going to happen faster in fraction 2 than it happens in fraction 1. So in fraction 1, the only alcohol there is because of the grape's own auto fermentation. In fraction 2, you get alcohol from the auto fermentation, but there's also an alcoholic fermentation going on the outside that actually diffuses into the grapes and can shut that down faster. So we tend to have more of that carbonic flavor profile when we have more air around and less of that fraction 2 kind of liquid environment around. The other thing is that alcoholic fermentation that's happening in fraction 2, that alcohol sort of causes the berries to burst and to split and to open sooner than if they're in the air. And therefore, we just don't have as much time for all of those things to occur either. So when we think, first of all, when we think about these, if we have a large proportion of fractions 1 and 2, then we would expect a little bit of a shift in the flavor profile to include some of the things that we see on this list. But of course, we also have an alcoholic fermentation going on, right? We have an alcoholic fermentation in fractions 2 and 3. So in 2, we've got those intact berries, but we also have the alcohol that's around them. And we have what's going on in fraction 3. So, the good thing about this is that alcoholic fermentation, it's working like we would expect it to. It's producing a lot of CO2 that's sort of pushing out that oxygen, which is good. It triggers our auto fermentation. That displacement of oxygen is also really important in terms of preventing spoilage. So we have to remember our grapes come in with all kinds of microbes on them. And if there's a lot of oxygen around, those microbes are going to use that oxygen to make acetic acid and ethyl acetate. And so by having this displacement of that oxygen with CO2, it does help to cut down on some of that spoilage. Now it's sort of, we have that alcoholic fermentation in fractions 2 and 3 is happening much like we would expect it to, except sometimes the kinetics are a little bit different. And that has to do with these bursting berries in fraction 2. So rather than getting all the sugar and nutrients at the same time, like you do in fraction 3, fraction 2 is sort of, as those cells are, or as those berries are bursting, they're giving like a little bit more sugar and a little bit more nutrient. So sometimes that fermentation can actually last a little bit longer and have a little bit less of the boom and bust cycle that we would expect in a traditional alcoholic fermentation. And then, of course, in fractions 2 and 3, if there are whole clusters in there, there are stems in there with them. Those stems do actually help with physical mixing. So sometimes we see a little bit less of a thermocline between our cap and the rest of the fermentation, just because those stems do help to kind of break things up a little bit. But of course, stems bring with them, they bring potassium, they bring methoxypyrazine, and they bring tannins. And so that potassium may cause a shift in our pH. Methoxypyrazines may sort of give us a little bit more green character. And we would certainly expect to have more tannin in these as well. Sometimes we might want that, sometimes we might not want that. So all of these things are occurring anytime we sort of load the vat with whole clusters. But again, depending on the winemaking decisions you've made in terms of maximizing or minimizing any of these given fractions, we would expect different amounts of that impact over time. So just keep those things in mind. We're going to sort of dig into a couple of aspects of that as we go into our experiment. So the first experiment comes to us from Kirsty Harmon. And in case you didn't see, Kirsty is actually the, I'm sorry, I know. Kirsty is the featured winemaker in Wine Business Monthly this month. So congratulations to Kirsty for that. And when you read her comments, you can tell that Kirsty has a real passion for experimentation. And she even gives a shout out to the WRE and to some of our experimenters. So thank you, Kirsty, for doing that, and congratulations. And so we'll move on there. We'll move on to your experiment. So you tell us about what your experiment was and why did you want to do this experiment?
Sure. So I have been chasing this carbonic experiment series for several years, probably. I've been doing it at least 4, but I think I've been officially experimenting on it for 3, because I really like the carbonic character. I like the lightness. I like the brightness that it can give to the wine. I enjoy drinking carbonically macerated wines. I enjoy Gamay. I enjoy Beaujolais. So I was really curious how I could mimic or get some of those carbonic characters in some of my wines. I also read that carbonic maceration can sometimes help to fill out the mid palate in wines. And I feel like the red wines that I make probably start okay, they end okay, but I feel like they have a bit of a dip in the middle. So I'm always trying to search for something to fill in that gap using the grapes themselves. So this year is a continuation of experiments that I've done in the past, but again, just trying to really push that, like the I guess phase number 1 of what you're talking about, the whole, the entire cluster. So loaded 3/4 of a ton of whole fruit that was not chilled into a tank that I can gas. In the past, I've used this tank, but not gassed, or I've used this. Thank you. There we go. Wait, do you want to take over, or do you want me to keep blubbering here?
Well, let's do a quick check just to make sure that we all are clear on the term for carbonic maceration. So carbonic maceration is a really kind of specific procedure, and we just want to make sure we all kind of know what that is and why that's different from the type of whole cluster that we'll see Tim talking about. So With carbonic maceration, we're talking about really, as Kirsty said, just sort of loading the grapes into a vessel that can be sealed, along with carbon dioxide, and essentially sealing it off and allowing that auto fermentation to occur. So that's sort of what the graphic is calling the first fermentation. And as you'll see there, like really when you're doing a carbonic maceration, the procedure itself was kind of described by Flanzy and his colleagues through kind of the mid 1900s. It's an ancient procedure, but it's one that was developed or described during that time. But really, when you look at it, it's like this is a pretty warm environment. It's like in the upper 80s, early 90s, and it goes on for like 7 to 12 days. So these grapes are just in there kind of auto fermenting for that time. And then in classic carbonic, you would just press it then. And then let whatever sugar comes out at that press continue fermentation in a separate tank. So it sort of gives us these very fruity, but very not tannic types of very lighter bodied red wines, very pleasant to drink, but maybe not with a lot of aging potential. And again, lighter in color. That's sort of what we would expect for example, a Beaujolais style wine. But then we also kind of have you can see in the graphic here, what we would think about for maybe a cru Beaujolais still has that portion to it, but then there's sort of some encouragement of tannic extraction with maybe some mixing within that vat. So you still have your whole clusters in there, and then there's some mixing of the whatever juice gets mushed down in there, a little bit of mixing there to get a little bit more of an ageable wine with a little bit more color. And then as Kirsty said, yeah, Kirsty, you have done, these are the ones that I could find of your experiments. So tell us a little bit about what you thought for your so the 2016 wine, you did a more traditional carbonic maceration, right? You stuck it in the tank, you pressed it off. Tell us about that wine.
Yeah, so that had a lot of fruit character, but zero color. It looked like a rosé, and I really couldn't use it for any real blending just because the color was so low. But I liked the character that we got. I liked the strawberry, I liked the kind of tutti fruitiness that we had. So in 2017, after 7 days of leaving it in the tank with a little bit of CO2, I decided to destem and do regular punch downs like I would a normal fermentation. So I liked that better, but still trying to chase a little bit more of the carbonic character. And we thought, well, the two things that we haven't really addressed and could address are temperature and constant CO2. So for 2020, I didn't chill the fruit. I left the tank outside under cover, and then we had continuous CO2 kind of going through the tank. It's not technically a pressure tank. It just has a fermentation valve on the top. And then I added just a gas inlet on the ball valve on the bottom. So that ball valve was open, the gas was going continually through, and then I did it so at a rate which was not exact, but enough so that I could hear it hissing out of the top. So I knew that CO2 was going in, and I knew that I had enough. And that the tank, actually, you could feel the sides of the tank, and before you could, kind of, there was a little bit of wobble to that tank in years past. This year, it was completely solid. So after 7 days, we did the same, opened the tank, destemmed the fruit, and did twice daily punch downs. The difference that this year was there was hardly any juice at all in the bottom of that tank.
Okay.
There was less than 5 liters of juice. So those whole clusters were really intact. And I was nervous about destemming them, but I saw a repeat of the experiment in 2017 where they destemmed really nicely. So it wasn't a problem.
Good.
And then after fermentation had finished, after negative bricks, I pressed off that bin.
So just to sort of make sure we're all understanding the flow of what happened here. So the graphic on the top would be a traditional carbonic approach. So going straight from your CO2 in the tank with intact clusters, press, go to tank, and finish fermentation. The second portion here would be more of a traditional red wine fermentation, and Kirsty did do a side-by-side here. So her control really was destemming, fermenting in T-bin, pressing, going to barrel. But the way that she's sort of approaching her carbonic at this point is carbonic in tank, but then destemming and allowing those to ferment in a T-bin to sort of get more of that color and phenolic extraction, then going through the rest of the process. So it's not a traditional carbonic in the sense that she still has that fermentation on skins, but it's not even really like the Cru Beaujolais version because she's taken the stems out. So just thinking about what we might expect to see in those ones. Okay, so, and then as she said, making sure that these are as warm as they can be, and the CO2 is on sort of a continuous. Okay, so that you know what's in the glass in front of you, for flight 1, we have a control and a carbonic. So again, control being done in that really standard style, and carbonic in Kirsty's modified. We should maybe call it modified carbonic style. So I'm going to go ahead and read these off in case you're doing this off of your phone or you don't have access, if you're calling in for some reason. If you are in group 1, wine 257 was control, and wines 267 and 477 were carbonic. If you're in group 2, wine 734 was control, wine 554 was carbonic, and wine 700 was control. If you're in group 3, wine 818 was carbonic, wine 273 was carbonic, and wine 890 was control. If you're in group 4, wine 169 was carbonic, wine 586 was control, and wine 707 was control. I'll put that back up before we sort of discuss the sensory. We'll take a quick look at the chemistry, and then we'll talk about what your sensory impressions were from these wines. The juice chemistry itself was pretty solid, and it meant that Kirsty didn't have to add any sugar or acid or nutrients in order to kind of keep the experiment the same for the rest of it. When we look at the fermentation kinetics, I've done these relative to day post inoculation. So basically, once they got in the tea bin, what did they do? We don't see very, very much difference here between the fermentation kinetics. We have a little bit of difference in temperature. That's more likely just due to the fact that it was a couple of days later and it was probably different temperature when those went in. So the general wine chemistry itself, basically, if we look at the pH does not shift very much. And again, Kirsty was not fermenting with the stems in there. So we wouldn't expect to see that big pH shift that we might see if the stems were present. We don't see a big difference in lactic acid. There's a little bit there, meaning that we might have had a little bit of malic acid depletion in the carbonic versus the traditional, but that's not a very big difference there. And then I think the most important thing here is really thinking about any potential spoilage that might have occurred along the way. And in this case, I think the volatile acidity between the traditional and the carbonic, at least one of the barrels of the carbonic was about the same. We have one of those barrels of carbonic with a little bit higher VA, but because barrel number 1 had about the same VA as the other two, probably what's ever happening in barrel number 2 might be more about the barrel environment than about the procedure itself. So in this case, that idea of like, how do we keep it clean going along? It seems like there was enough CO2 in there to kind of prevent that buildup of volatile acidity. But another thing that we think about when we have all of those whole clusters in there is the production of ethyl acetate. So ethyl acetate is made primarily by lactic acid bacteria, Pichia and Hanseospora, all of whom are present on your grapes. And if there is oxygen around, you can have some pretty high spikes of ethyl acetate in whole cluster or carbonic fermentations. But in this case, we see, we do have a little bit higher ethyl acetate in the carbonic versus the traditional. But the other thing to remember with ethyl acetate is that the detection threshold for ethyl acetate as a spoilage character is it's between 90 and 150 milligrams per liter, depending on the wine environment. So any ethyl acetate that Kirsty has here is really well below that number. And when it's below that number, it's actually kind of been shown to lend some complexity and some interest and even fruitiness to the wine. So in this case, that carbonic maceration, part of that tutti frutti might even be because there's some ethyl acetate in there. I mean, again, not a spoilage character in this particular sense. So Kirsty did a good job of keeping enough CO2 in there to kind of keep that spoilage from happening. I did notice that we had a little bit, there's this weird thing with the SO2, and I think I just figured out what was going on there. We did sort of see that the carbonic seemed to have less free sulfur than the traditional did. I didn't really know exactly why, but then I looked back at the protocol and I realized that the traditional fermentation got SO2 because that's part of Kirsty's normal protocol. So the traditional one got SO2 at crush, whereas the carbonic didn't, because that SO2 could be sort of causing some of the breakdown in the skins. And so some of the difference in the free sulfur here might just be because of that difference in the original add. When we look at the color, color was a big problem originally in that carbonic experiment. We see that the color here is pretty comparable between the two. We do need to remember we have less free sulfur in the carbonic barrel. And so the higher color intensity in the carbonic barrels may also just be because there's a little bit of difference in the free sulfur. But in that sense, we've sort of, it's not a problem to have that. We're not seeing the carbonic is causing a problem. And then lastly, on the chemistry, we do see, we see that we actually have a little bit more tannin in the carbonic and a little bit less anthocyanin. Again, we didn't have any stems in there, so that might have just been because of extraction differences between the two fermentations. But I would be curious to know if anybody found either saw any differences in color or seemed to perceive any differences in astringency along the way. Okay, so that is what we have for chemistry. So we're going to sort of move into looking at some of the aspects of what you guys thought about these wines. And so while we have that discussion, I'm going to stop sharing my screen so we can see each other again and so I can see the chat. So let me go ahead and see if there's any questions that have come into the chat that we can answer before we jump into sensory. So so Tim's asking if the carbonic maceration vessel, is it a pressure tank? Kirsty, you want to answer what kind of tank you're using?
Yeah, not technically. No, it's not. I wouldn't feel comfortable doing any more than just a little bit of CO2 kind of going in. And I have that fermentation top at the top. So if the CO2 builds up too much, it can release it. So.
Great. And then Tom is asking some clarifying questions or clarifying comments about auto fermentation. Yeah, Tom, it is definitely an enzymatic reaction, and it's basically, again, it is producing CO2. So CO2 is coming out of the grapes as well. So those grapes are popping for a lot of reasons, but if you're sort of eating away at them on the outside and you're giving pressure on the other side, you do have a faster breakdown than if you don't have that alcohol bathing on the other side. So I would say that even in carbonic, like Kirsty said, there is a certain amount of juice that builds up on the bottom. But again, it's pretty minimal compared to the amount of bursting that you get in fraction 2 of your whole clusters. So, but yeah, definitely there's you mentioned the temperature as well, and yeah, everything I read basically was somewhere in the mid 80s and even early 90s, depending on what the recommendation was. And we can think about temperature there just in terms of all chemical reactions happen faster when it's warmer, and so maybe it's sort of the race against time in that sense. We get more oomph from that along the way. So,
and I would be very surprised if I reached anywhere near those temperatures. I mean, especially as it got a little bit cooler outside in general, I don't think I reached those temperatures. And unfortunately, I don't have a way of heating that tank.
Yeah. I was thinking about this. I think that, particularly since this was an experiment from 2020, like, you put your grapes in there unchilled, which certainly helped, but our overall temperatures during harvest this year were a lot cooler than they were for example in 2019, and so I think you get a certain amount of that enzymatic reaction happening either way. It's just a matter of how you can really goose that. So the first, I've launched the first poll question, and I'm curious to see if you all were able to tell the difference between the wines. And if you were able to tell the difference, maybe you can put into the chat or you can unmute yourself and let us know what were some of the characteristics that you felt were different between these two wines. It seems like we have a lot of folks able to tell the difference. So what in your description was different between the carbonic wine and the control wine?
Well, I won't be the shy one. So I noticed the difference mostly in the nose at first. And it was going back to it after I tasted it, was even more pronounced. But all of them were kind of brambly and medicinal, but I got a little bit more of a candied alcohol kind of texture on the
Carbonic.
Thank you. So yeah, and then on the palate, I did get a little bit more richness and something kind of like a graphite character that wasn't really a fruit character, but was more like a kind of like a tannin characteristic with just a hint of that sourness that tannins can give you, but just completely almost intangible. But again, to go back to my original point, is the nose is what did it for me. And that's it.
So it looks like we have an overwhelming number of people that were able to tell the difference between these wines. I felt like, and I certainly was as well. And I felt like this was one of those, sometimes we get discouraged in the triangle test and we think something's wrong. Like in this case, they really are different. And I think, you know, it is one that most of the time it's there. Now, sometimes sometimes we can't tell the difference, but in this case it was. So I'm glad that we had a good response there. We have a couple other things coming into the chat in terms of the differences. So Tom felt like the carbonic was softer and the control had more grippy tannin to it. Beth felt that there was more cola, more cherry cola and Jolly Rancher cherry with the carbonic. I think Jolly Rancher is one of those descriptors. When people ask like, what's tutti frutti really? I think we all sort of, Rick used the word candied, candied something. I think it's sort of, those are sort of hinting at the same concept there. More berries in the carbonic. I felt that it did have a lot of berry character to it, and more fruity and higher perception of acidity on the carbonic. And again, the acidity itself was pretty much the same, but all of those other characters can kind of give it a brightness, I think, for sure. So getting back to the original winemaking goal here, Kirsty, was to use as a blender, correct? To sort of
the
two.
That's right, but I really like the carbonic, and so I have, because we use growlers and because I do things in kegs, I probably will keg a little bit of this just as is, because I think it's fun to drink and taste, and you know, not something I would put away and age, but I think you could drink it on a day like today and be quite happy. I would be anyway.
Me too.
Yeah,
I've got another poll and I don't know how to get there. Hang on. Okay, so I'm going to launch another poll along those lines, thinking about those original winemaking goals of using it as a blender. And actually, if you have any left in your glass, you could combine the two and see how you like the third versus the two. I realize I asked you a lot of questions, so you may or may not have anything left in your glass. But if you do, that would be sort of a way of kind of getting there. So how well do you think it meets that winemaking goal of kind of trying to give a little bit more richness and a little bit more oomph in the middle of the palate there? And then this is my question for Kirsty is, you know, given the results, do you think it's sort of worth doing all that extra work and taking that extra risk, right? It takes longer and there is that extra risk of spoilage as you're kind of going through that carbonic process. So what do you feel in terms of the wine that you get on the other side of it, but also you're the one that did all of that work. So you're the one that knows best how much that entailed.
It's still fun. It was a fun project to do. I enjoy the results, so I do think it's worth the risk. It is not anything I would try with fruit that didn't look perfect. So I think there are years to try carbonic and there are years not to try carbonic. And luckily I had a really nice lot of Merlot. So I definitely want to do it again. I would like to increase the volume. I have just 2 of those little tanks because I do think I like the character. I like what it brings. So I'd like to do it on a larger scale. The only limiting factor I have really is a tank that I can seal properly and put enough CO2 in. So that's my limit. Yeah. But I think I would like to try this on other variety. I won't ever try Cabernet Franc again because that didn't go so well.
Yeah.
Potentially Pinot Noir, potentially Petite Bordeaux, potentially Grenache. So yeah. We'll see.
Yeah. So Kirsty brings up a good point in that, like, some of these varieties are gonna kind of break down more. Some are going to be a little bit more solid in terms of loading them into the tank. And we'll touch on that when we talk about Tim's experiment as well. So let me go ahead and end the poll here and share the results. It does look like most of our respondents did feel like this does at least somewhat of a good job or a very good job at sort of giving you that piece in the middle. And, you know, those that weighed in did feel like it was worth it in terms of at least the philosophical idea of it. I don't know how many folks out there have done carbonic, but it does seem like it's well received in that sense as well. So we are going to maybe move on, if there, well, first of all, are there any other questions or comments? I'll get to the section here, but before we move on to carbonic, any other questions or comments or suggestions for Kirsty before we move into Tim's experiment? Sharon does say that she saw the color difference. And Sharon, totally, I feel like the nose was just so different between the two for sure. And the control was more tart, where the carbonic had darker fruit and softer. And some of that might be the body of it too, kind of giving us that. And then Jordan wants to know, were these blended yet per your original goal? Have you blended these yet, Kirsty, or are these still separate?
They're still separate for now.
Okay. Okay. And then Beth wants to know, why didn't the Cab Franc go well?
I think perhaps it was just the year, and perhaps I got pretty cocky because I thought the Merlot was going well, that I would do Cabernet Franc, and then I sort of forgot about it, and it turned more kombucha than I would have liked. I think the skins of Cabernet Franc tend to be a bit thicker, and perhaps there's some issue there. I don't know. With Cabernet Franc, I prefer whole cluster inclusion than carbonic, I think, but it was probably more me than the Cabernet Franc.
So speaking of sort of variety differences and Cabernet Franc with all of this, we'll go ahead and move on to Tim's experiment, but we will make sure that we have just a little bit of time at the end to wrap things up as well. Oh, Rob says that the two blended together is definitely a winner. So there you go. That's a good endorsement right there. So, okay, so let's go ahead and I'll go back to sharing my screen so that we can get to the next experiment. Oops, there we go. There we go. Sorry. There we go. All right. So our next experimenter is Tim Gorman, sorry. So Tim, tell us, what was your experiment and why did you want to do this experiment?
I was just copying a whole cluster experiment that Matthew Fino did at King Family. I tasted a Cab Franc that he did whole cluster, and then he also did one last year, I think, for the WRE with Merlot. I'm not even sure, actually. I don't think it was Franc.
Last year was
okay, figured out, right. So, but he makes a natural starter, yeast starter in the vineyard. And I just wanted to see if I could use, industrial yeast that I can purchase and still get similar results, because I was impressed with with his results from the whole cluster. And I just wanted to, see if I could take that. What scares me is that concoction being made ahead of time, this yeast starter that could be, in my opinion, I don't know, all over the place with what it's doing versus just setting up an experiment where I'm doing something I normally do versus this whole cluster, but keeping the yeast the same.
Great. So this was basically, it took some of the principles from Matthew's experiment last year, but then moved them into the normal flow of work at Tim's winery. And I would say that the difference there between the inoculated and non-inoculated, sometimes it feels like it's a little bit less risky. There's a lot of risk that feels like it goes into whole cluster anyways. And so sort of dialing that down one notch. I realize those of you that are ambient fermenters out there don't feel like that's risky. And if you feel comfortable with that, then that is wonderful. So Matthew did do an experiment with Petite Bordeaux last year. Unfortunately, we hadn't gotten to the sensory session for that before we were no longer doing in-person sensory sessions, so you all didn't get to taste it. So I'm really glad that Tim wanted to repeat some of the protocol for that and allow everybody to have a chance to taste the results of that. So thanks, Tim, for your willingness to validate the results that we saw from King Family. So if you missed it, we did, and Matthew and I did do an Instagram chat about it, and the whole chat is on the YouTube channel if you want to listen to that whole thing. But some of the take-home messages that Matthew had as part of his protocol that Tim put into his protocol was, first of all, to sort of get that fermentation going quickly on the bottom. So basically what the protocol itself is to load whole clusters into your fermentation vessel, but foot stomp on the bottom in order to sort of get some mush going on so that you can get a fermentation started. And the idea of getting that fermentation started quickly, both with warm fruit and by inoculating either with the vineyard starter culture in Mathieu's case or with the commercial yeast in Tim's case, to get that CO2 working to displace the oxygen so that we can sort of do that fight against any spoilage characteristics. So again, starting with warm grapes for that reason, and then also starting with warm grapes, as we've seen, does help sort of speed up some of those auto fermentation processes. So we might get a little bit more carbonic character there because we're starting a little bit warmer. And then one other thing was Mathieu did his experiment on Petite Bordeaux, and Tim is working in Cabernet Franc. And as we've already just mentioned, the Petite Bordeaux and Merlot are probably going to hold together. They're a little bit less well than Cabernet Franc. Cabernet Franc, I think you're going to end up with more whole clusters at the end than if you did this with Merlot or with Petite Bordeaux. So there are a couple of nuances that are a little bit different there, but I think the overall sensory gives us a good idea of what's happening there. So Tim, tell us a little bit about how you actually set up your experiment. You had 3 treatments.
Yeah, so essentially my control was destemmed fruit into a bin and then inoculated. I did the whole cluster, which was whole cluster, halfway, filled the bin, went in, stepped it all down, and then covered the second half with whole cluster. Inoculated the lower half, sorry, and then covered. And then I did a hybrid of those two, which was half destemmed bin, and then whole clusters on top of that. Also inoculated, yeah.
So for those that
sorry, it's written there.
no, it's good. Like we do that on purpose. You did a good job. So I did also put this because throughout we're going to call these treatments 1, 2, and 3, and so we know which of those 3. I do put a key on the bottom of the slide too because it's hard to keep track of them sometimes. So Tim, for those that have not done foot stomping of whole clusters, when you put your 50% in there and did your foot stomping, can you tell us a little bit about, like, you know, how much berry breakage does that feel like? What is that in terms of sort of maybe compared to just destemming the fruit?
I'm actually first time I've had that question. So it was, as I recall doing it, like a matter, I didn't want to, I think you could totally grind this stuff up, you know, if you stayed in there and marched all day. So I was just trying to just lightly break into the clusters a little, obviously not trying to get every berry because you would, you know, and, you know, I'm so svelte. I'm just kidding. I don't know what the gravity of my weight pressing, you know, versus another person obviously is going to be different, as well as the height that's in there. You know, in other words, if I had only put, say, a quarter of a T-bin, I think I would be crushing a lot more finer. And the other thing I was worried about is breaking a lot of the rachis, the stem in there if I was too aggressive. So essentially, I just tried to step it down so it looked like the whole top surface had been stepped, right, if that makes sense. And it was a decent amount of juice. It definitely, I would say the volume was taken down, you know, 50%, you know, height wise from the start. But that's a guess. I didn't measure it.
Well, I think that, like, the idea of the foot stomping is really to kind of get enough juice in there that you can get a fermentation started. And I've done some foot stomping myself, and it's sort of, I think it's just it's good to remember that there's still a lot of intact berries in there, and it's still pretty solid. It's not the same. Texturally, it just doesn't feel the same as destemmed fruit. And particularly when you try to go in and do cap management on anything like that, it's still pretty solid. It's not like the destemmed fruit that's just, there's a lot of juice out there. So I do feel like there is that difference along the way. Okay, so you know which things are in your flight. If you are in group 1, and I've listed these by treatment, and then there's a key for the treatments on the bottom if you kind of need to go back and cross reference, only because I couldn't fit all of that description in the little boxes. So that's that. So if you are in group 1, 644 was treatment 3. That's the foot stomped whole cluster. 359 was treatment 2. That's kind of the 50-50. And 989 was treatment 1. That's our 100% destemmed fruit. If you're in group 2, 877 was treatment 2. 768 was treatment 1. 915 was treatment 3. If you're in group 3, 167 was treatment 1. 624 was treatment 3. And 409 was treatment 2. If you're in group 4, I have to move my chat box to see. If you're in group 4, 805 was treatment 2, 937 was treatment 3, and 823 was treatment 1. So with that, I'm going to stop sharing my screen. Did that stop? Yep, stop sharing my screen so that we can talk about your sensory impressions. Wait a minute, we didn't talk about chemistry, did we? I just jumped right past chemistry. So sorry. I'm going to share my screen again and show you some chemistry. My goodness. And now it doesn't want to go back. There we go. I'm just so excited to talk about what these wines taste like, Tim. I'm excited. All right, so we're going to go through the chemistry briefly. Okay, we do see that we did get fruit chemistry for treatments 1 and 3. We didn't know initially if we were going to be able to do 2, so we just got fruit for, we had Virginia Tech do the fruit chemistry for 1 and 3. These were very similar in terms of their chemistry, and so we would imagine that treatment 2 had very similar starting chemistry as well.
Basically, yeah.
When we look at the fermentation kinetics, there's some interesting observations, I think, and Tim and I have talked about this a little bit already. Much like we would expect, the control went really quick, or went like more quickly than the other 2. That makes sense. There's a lot of juice in there to just sort of get things going. In this case, we had a little bit slower progression in treatment 2 than in treatment 3. So that means that our destemmed, the one that's 50% destemmed and 50% whole cluster actually went a little bit slower than the one that was foot stomped and whole cluster. And the one thing that I was thinking about in terms of that is really when you're thinking about the amount of juice that you're actually, when you're taking your fermentation kinetics, you're taking that from the juice that's on the bottom, not from what's happening in the berries. And so when you have less juice on the bottom and you inoculate with the same amount of yeast, you actually have more yeast per juice in the foot stomped one than the yeast per juice in the destemmed one, just because you have more juice in the destemmed one. And so that might be one of the reasons that we see a little bit of shift in those fermentation kinetics. That's been the one thing I've been able to think of. If anybody else has a hypothesis about why that's a little bit slower, please let us know. In the end, though, it wasn't that much slower, and everything really did finish in a reasonable amount of time. So there's that portion of it too. So that might just be, a small affect as well. When we look at the wine chemistry, we can see that once again, this approach, Tim did a really good job of controlling the potential spoilage characteristics. So the VA is very similar between the 3 and certainly at a very acceptably low rate. We also see that ethyl acetate, though he sees a little bit more ethyl acetate in treatment 3, again, it's well below that threshold of about 90 milligrams per liter. So in this case, probably again, lending richness and complexity and fruitiness to the wine, as opposed to giving off any of that nail polish remover. We do see a little bit of increase in the pH as we get more stems along the way. And again, that's probably a byproduct of the fact that we've got more potassium coming out of those skins or those stems, causing a little bit higher pH. This is a pretty high pH wine to begin with. And so, but in this case, unfortunately, the stems pushed it even further that way. And again, the lactic acid, we don't really see any difference in potential malic acid that turned into lactic acid here. It looks like we didn't get too much malic acid consumption as well. So that's where we were with those. And then there we go. The color metrics, in this case, it's a pretty light, we have a pretty light color intensity in the wine to begin with. And so even though it looks like treatment 3 is a little bit higher intensity, it's a very small difference and probably not one that that is too notable in terms of what we need to think about with whole clusters. Sometimes we do have less color with whole clusters. Doesn't seem to be the case here. We just sort of don't have a lot of color. I think that's an issue that a lot of us saw this vintage, is that a lot of our Cabernet Franc didn't have a lot of color. And then in our phenolics, we do see an increase in tannins with an increase in stems. Again, remembering those stems bring tannins with them. So if you're, some people like that in the wine. I know Mathieu, when we talked about the Petite Bordeaux, one of the things he wanted from the whole cluster was to have a little bit more natural tannin, to give a little more punch to that Petite Bordeaux. Some folks don't like that, or if you're dealing with a wine that already has a lot of tannins, sometimes those stem tannins can be off-putting. So that's a matter of preference and winemaking goals for that particular wine. We do also see a little bit lower anthocyanins here. Again, sometimes stems can also absorb anthocyanins, so sometimes we see a little bit of drop off with whole clusters in those as well. Okay, so now I'm going to stop sharing my screen so that we can talk about what you all thought about the sensory characteristics of these wines. And I'll start by launching our next poll, if I can figure that out. There we go. Okay, so I'll go ahead and launch the first poll question here, and that's just how different did you feel like these wines were from one another? This wasn't a triangle test. You had 3 different wines along the way. But how different did you feel like they were from one another? And then maybe if you can put into the chat box what you felt was different about them. So what are some of the descriptors or the characteristics that you felt sort of set one of them apart from the other one? I originally had this poll set up as a scale of 1 to 10, and then I realized it was going to get way too complicated to do that. So, okay, so it looks like most people feel like they're somewhat different or moderately different. That most people were able then, I think, to tell some difference between the wines, but there are some, they're relatively subtle. They're not, maybe not quite as stark as the differences that we saw for Kirsty. Rick says that he likes the viscosity or the palate weight of the 50-50. Rick, do you want to tell us a little bit about what you like, what that means for you in terms of, do you feel like the one is too light or too strong, or just it just gives you a good balance?
I think overall the balance and there was a little, it just seemed like it had a little bit more sap to it, a little bit more complexity than the other 2 did. So that's all I got.
Okay. Okay. What about you, Tim? What did you think about when you're doing this experiment? You know, what did you think in terms of what you were trying to achieve in the wine? Was there one or the other that you felt achieved that the best?
Well, so I mean, from the get-go, the year 2020 I mean, you saw what the fruit came in at. So I was dealing with stuff that I was kind of like, I don't even know if this is going to work. But going through it, and you know, it's chapelized. Yeah, I could taste a difference, especially in barrels. Getting these samples, we were talking about it just before we started, and to finish that now that I can, I was just nervous that what I was preferring, they don't taste like the barrel samples to me. They're different, but I totally got it right. You know, I picked them out right, which made me, you know, validated something. And yeah, I totally, I prefer the whole cluster. I just think what I need is a This was a vineyard. This is the first time I've purchased this fruit, and I was so I'm not used to the vineyard, and I think I need a better year. The fruit was beautiful and clean. I was really happy with that. But I think it would. I think this whole practice needs to be retried with sort of more mature fruit, or it, for a lack of a better way, just a better vintage to try it again with, certainly more color. Did I answer your question?
Yeah, I mean, I think that, like, one of the things that you get with whole clusters is, generally we get less color, and this was already a difficult color year. The other things we get with whole clusters is sometimes you get less varietal character because you have more of that auto fermentation character. And it would really be interesting to see what this would do in a year where you maybe have more varietal character to work with, right? If your Cabernet Franc was, if it was not as Cabernet Franc-y as it always is because it was cold and it was rainy and we were struggling to get there, then it would be an interesting thing to see. When you have Cabernet Franc, what's the treatment, what's the balance of those processes that you like the best?
Right. Yeah. I mean, it was, that to me, that was the hardest, like going through after I have, resultant wine and tasting it, I couldn't go, this is, especially the control. I'm like, the control tasted different than I normally would, my normal Cabernet Franc taste. And I'm going, what does this mean? So I guess actually the whole control side was the biggest issue. I'm obviously I can see the whole cluster effect. I just want to try it again. Give me see how it works out.
Well, I would love to get. I would say that the whole cluster experiments are some of the most popular experiments for WRE. We get such a great turnout to this whole cluster thing. So I would love for you to do this again so we can continue to talk about this. So I did launch a poll to have you guys weigh in on what your preference was with the three. So if you haven't voted on that, go ahead and do that. And then also we have a couple of comments that have come into the chat. There's a comment that there was more extraction on number 2. So the process of number 2 seemed to sort of lend more perception of tannin along the way. And that kind of makes sense. You've got sort of more alcoholic fermentation happening than treatment 3, but you have more stems in there than treatment 1. So maybe there's some nice balance point of tannin extraction there. And then Beth feels like there's more sweet or baking spice on the 50-50 blend. And I do feel like auto fermentation, some of those characteristics for auto fermentation certainly go into the sweet baking spice kind of category for me. I'm sorry, in the 50, the foot stomp whole cluster blend. So not that, so the treatment 3. So yeah, and that one have the most whole cluster. So that characteristic was certainly coming through. And then Rob is saying that he got richer fruit profiles from treatment 3 compared to treatment 1. So again, that fruitiness of the whole cluster coming through. Treatment 1 was more red fruit versus a black cherry plum in treatment 3. And then treatment 2 is harder to separate as a distinct difference, which makes sense. It's sort of in between those two. I actually felt like treatment 2 had a little bit more complexity, maybe because it has more sort of perceptible characteristics for all of those. So it looks like let's look at our poll results here. It does look like some whole cluster inclusion is seen positively. There was sort of almost a tie between treatments 2 and 3 in terms of preferences. And I think even in the chat, we can sort of see what some of that is coming from. So before we wrap up today, though, too, I wanted to ask if I know there's a lot of other folks in the audience that have done whole cluster fermentations and carbonic maceration. And clearly there's a lot of folks that are thinking about doing these or wanting to play with that. So for those of you that have done these types of experiments, are there pieces of advice that you would offer or things that you'll say, this is the most important thing in terms of setting this up? Or things you need to remember in doing that. So we've already heard some things. I think Kirsty has already talked about how important it is to have really clean fruit in doing these experiments. And we've also talked about that continuous source of carbon dioxide. But are there other pieces of advice that folks would give there? And again, you can feel free to unmute yourself, or you can feel free to write into the chat box if there are some things that you wanted to contribute there. If everyone's going to be shy, I do have a slide, but I thought I would give other people a chance. So there are a couple of things, and these really are things that I have learned from all of you who do whole clusters, but I did put them together on a slide so we can look at those together. Again, clean, dry, intact fruit, having a carbon dioxide plan. You know, Kirsty had CO2 gas going in there. Tim had a fermentation going. I know at Early Mountain, they use dry ice, but just making sure that you have a really good source for carbon dioxide. We talked about this a little bit with Kirsty about the choice of your tank. First of all, realize if you have any whole clusters in there, the whole volume is going to take up more space. So if you're, you know, doing if you're thinking about which tank to put your fermentation in, remember that your whole clusters take up more space, and don't get yourself stuck in a you know, boiling over fermentation. And then the shape matters. So tall and thin tanks, you just have a heavier column on the top, and you'll end up with a little bit more juice on the bottom. Whereas shorter, fatter tanks, you just don't have that as much. So for example, for Kirsty's Carbonic, she sort of had one of those square tanks, which was kind of a shorter, fatter tank than the taller, skinny tank. We've already talked a little bit about varietal differences there. Addition rates are a little bit hard here, because if you only have a little bit of fermenting must in there, but you're doing your entire acid addition, sometimes you can kind of overwhelm things. So think carefully about how much juice you have versus how many berries you have in there. Realize that intact berries, when you press them, oftentimes sugar comes out. So that's fine when you have kind of an ongoing fermentation. But if you are doing some whole cluster inclusion and then doing some extended maceration, for an example, and then your yeast have starved and your fermentation is cold and then you press, you may end up with some trouble getting that last bit of sugar to go. And you may have some spoilage organisms like lactic acid bacteria or acetic acid bacteria that would be thrilled to eat that sugar and make some nice acetic acid for you. And then we've already talked about the propensity for stems also potentially sort of pushing your pH. So if you have that you know is already high pH fruit, you might want to just sort of consider that carefully. So I will stop my share there. I did see that. Okay, so and then before so again, if anybody else has anything to share there, we'd love to give you a chance to do that. You can put that into the chat. We'll hang around for a couple of minutes, but I know I am over time here. Before we go, I just want to make sure to say thank you to Tim and to Kirsty for sharing their experiments with us. Thanks to the Wine Board for funding our program. I want to give a big thanks to Jolie Thompson, who is the laboratory tech at Veritas. She is the one who has been preparing all of these little sample bottles for you and putting them in the packages and getting them to UPS. Which is really a tremendous undertaking. And so I have a big thank you to give to Jolie for that as well. So again, if you're interested in that March 18th tasting and you have not yet RSVP'd, go ahead and shoot me an email and I will put you on the list to at least get to the link for that. So thank you all so much for your time today. I'm sorry we ran a little bit over time, but hopefully some of these experiments, I feel like they were really great wines to be able to taste what these procedures